70-741 Lesson 12, Implementing High Performance Network Solutions. When we talk about high performance network solutions, what are we talking about? We're talking about implementing NIC teaming, combining NICs to provide redundancy, resiliency, increased bandwidth, higher performance. Switch embedded teaming, SET, identifying when to use either the NIC teaming or the SET. Receive side scaling, configuring network quality of service, configuring SMB direct on remote direct memory access. Say that real fast. Enabling and configuring SMB Multichannel. Many other features to enable high performance networking in this lesson. So let's take a look at exactly what they're talking about. Back in lesson 1, we didn't learn, we reinforced how to configure IP settings, including addresses and gateways and DNS settings, and that we know that to be able to use that network adapter, to be able to configure the settings on that network adapter, we still have to have drivers loaded for the adapter. Remember, those drivers provide the software interface to the hardware. And Windows includes a lot of these drivers already, so that you may not even need to add a manufacturer's driver. If we open up the Network and Sharing Center, and we're going to take a look at this here in just a few minutes, we can open the properties for a network adapter, and in there we can configure client for Microsoft Network. This says, hey, are we connecting to a Microsoft network? Yes, this is something we want to have enabled. File and printer sharing for Microsoft Network. Allow your computer to share files and printers in a Microsoft network. So this is where that all starts. We can configure IPv4. We can configure IPv6. So remember that unless you're on a system that is DHCP enabled, you're going to have to configure IPv4 or IPv6. If you're on a server, in all likelihood, this is the route you're going to go, because servers typically are going to use what type of network address? Yes, a static address, not a dynamic, a static, because we want our client systems to always know where to reach the server. Server address needs to stay the same. We can configure link layer topology discovery mapper, IO driver, and link layer topology discovery responder. This is basically for home use. You're not going to see this on your business network. So what is NIC teaming? Depending on whose technology you're referring to, it may be called NIC bonding, could be called balancing, could be called link aggregation. Depends whose technology it is being spoken about. It's a Windows feature that enables administrators to take multiple adapters and combine them into a single entity. And as I previously stated, this gives you higher performance. It also gives you fault tolerance. Virtual machines in Hyper-V can also take advantage of NIC teaming. But understand that in the virtual machine, NIC teaming is limited to teams of 2 adapters. Whereas on the host operating system, the physical machine, you could create a NIC team to contain up to 64 network adapters. So how do you go about that? First off, you have to create the NIC team in Windows Server 2016 host operating system. So understand, before you can do that, can you do that if you only have a single network adapter on your system? No. Minimum of 2 network adapters. In Hyper-V Manager, you create an external virtual switch using the NIC team. This is on your host system. You would create a NIC team on the Hyper-V host server. That would give the appearance, let's say you have 4 network adapters. You have 4 1 gigabyte adapters on your Hyper-V server. You create a NIC team combining all 4 of those into the appearance of one NIC. So they were 1 gigabyte network adapters. It now appears as a single 4 gigabit per second network adapter. Then in Hyper-V Manager, you would create an external virtual switch that utilizes the NIC team, not an individual adapter. And then, of course, you would configure the network adapter in your virtual machine to connect to the virtual switch representing that NIC team. So take physical adapters on physical server, combine them into a NIC team. The NIC team has a name just like your physical adapter, Ethernet, private network, whatever it might be. You call it NIC team 1. And then in Hyper-V, instead of creating a virtual switch using the private network or Ethernet adapter, you do it using your NIC team. And then you connect that to your virtual machines just the same way as we would connect a normal switch. Understand that there's two different ways to configure NIC teaming. Switch independent mode, switch dependent mode. They appear in the system that has the NIC teaming, they work the same, but they function differently. Switch independent mode, all the network adapters are connected to different switches. So this gives you switch fault tolerance. So if you have two network adapters that you're building your NIC team with, and you connect each one of those network adapters to a different switch. You then create your NIC team using switch independent mode. If one switch fails, your NIC team still stays up because the other switch that has one of the network adapters connected to it is still online. Static teaming and what's called LACP are switch dependent modes. They're not switch independent modes. Switch dependent modes means all the network adapters on your system are connected to the same switch. This provides a single interface with their combined bandwidth. So what is SMB Multichannel? Well, Server Message Block SMB is also Common Internet File System, CIFS. It is a client-server file sharing protocol. It was created all the way back in 1984 by Microsoft. So remember NTFS, that's your file sharing protocol on your system. If I want to create a file share, or I want to give multiple users on the same computer access, well, the server message block and the CIFS, this is a client-server file sharing protocol. There's been numerous versions over the year. It started out with SMB 1, and then 2.1, 3.0, 3.02, and 3.11, and you can see that they're associated with the newer versions of Windows as time has progressed. Quality of service. What is quality of service? Quality of service is ensuring high quality performance for critical applications. It's a collection of various technologies. It measures network bandwidth, changes in connections, looking for congestion or availability of bandwidth, and it'll prioritize or throttle traffic as necessary. We use this principally with the concept of a converged network. And you remember from your Network Plus reading about converged networking, this is when you bring all your data, your voice, your video, cluster traffic, management traffic, all onto a single network infrastructure. So you needed to have a way, if you're going to do all this, remember voice is very latency sensitive. If you have voice traffic being carried on a network that has a lot of other traffic and there's high utilization and voice can't stay prioritized, then the voice it's going to get choppy. It's going to cut out. You can't have that. Well, voice is very latency dependent. It wants very low latency. So quality of service is that technology that helps to prioritize that traffic to make sure that your voice traffic never gets interrupted. What is Network quality of service with data center bridging. Well, it's a standard and it supports converged networks. So using that data center bridging, the converged network adapters with the dedicated iSCSI host bus adapters and other related switches, you have to have support for hardware-based quality of service and other features of DCB. Some of those features are congestion notification, priority-based flow control. That's what controls your flow of data. That's how it prioritizes what data needs to take precedence. Enhanced transmission selection and DCBX, data center bridging capabilities exchange. RDMA with SET. SET is set embedded teaming. RDMA is remote direct memory access. So you can form a converged network by combining your switch embedded teaming with remote direct memory access. This allows you to utilize fewer network adapters in your servers. So this is an alternative to NIC teaming. That's what switch embedded teaming is. This enables you to use a Hyper-V virtual switch to team up to 8 physical network adapters located on the same Hyper-V host. So this is, instead of creating a physical NIC team on the host, you do this and it creates a Hyper-V virtual switch with the 8 physical network adapters. So you don't create a NIC team, you're going to run a PowerShell command and it's going to create a virtual switch that combines the network adapters into one or more software-based virtual network adapters. So you can't use it if your network adapters are slower than 1 gigabit per second or gigabyte per second, right? You have to use standard network adapters. They're faster than, remember, if you've got an older system, you could use a legacy network adapter. You could configure your network adapter in Hyper-V to be a legacy network adapter. You need to use the standard network adapter. They're faster. They reduce the CPU overhead. You can also use VLANs. This helps you isolate network traffic. Remember VLANs from Network Plus, right? You can also access network adapter hardware acceleration, virtual machine queue, IPsec task offloading, and other features. So these are the ways that you optimize network performance. We're going to take a deeper look into some of these features later on. You'll be looking at these features in greater depth in your lesson. So from the lesson perspective, we covered configuring IP settings, to be able to configure your IP settings. First, you have to have the appropriate driver to allow you access to the adapter. The concept of NIC teaming, what a converged network is, what the concept of quality of service brings to the table, the fact that we can use an alternative to NIC teaming called switch embedded teaming, and finally virtual machine queue. That's a synopsis of your lesson. So in terms of your lesson, understand a lot of these key terms that we just went through. Make sure that you fully understand them. So when you look at your network adapter properties, you'll see the various settings. And we're going to take a look at these on a live system here in just a moment. But understand the definitions of what each one of these things do. Okay? It's very important. Now, if you click the configure button in those Ethernet properties, it takes you to a different screen. And here you can see all the different options that there are, and make sure that you've read through this and that you understand what each one of these items do. It's very important that you understand that. So we ran through what NIC teaming is. Well, how do you actually create it? Well, you create the NIC team in your host system. you're going to select how you want to do it. So in Server Manager, on the All Servers, you have to select Configure the NIC Teaming. You're going to do Tasks, New Team, you're going to give it a name, you're going to select the adapters that you want to use, and then you'll select the way that you want that NIC team created. So let's take a look at that on a live system. So over here is a server that's running, and this is a server 2016, and you can see it has four physical network adapters: Ethernet, Ethernet 2, Ethernet 3, and Ethernet 4. On Server Manager, NIC Teaming is enabled. So it's already been, initially it says disabled. When you click on it, you enable it. You're going to go in, and let me get that one screen back up here so you can see. There we go, and there we go. Okay, so if I go into if I click on one of those adapters, you know how we want to go, we want to rename our network adapter, or we want to configure a network adapter. We go into network connections. I brought up the properties for NIC Team 34114. It looks the same as a regular network adapter, except if you notice, it says the speed is 2 gigabits per second. That's because NIC Team 14 contains Ethernet 3 and Ethernet 4. These two network adapters of 1 gigabit per second are combined to give available bandwidth of 2 gigabits per second. So much higher transfer rates. If one of these network adapters it fails, it has a hardware failure, or it has a driver failure, or a cable failure, the NIC team stays up and it simply drops to 1 gigabit per second. If you look at the properties screen looks the same as a regular network adapter. Client for Microsoft Network, file and printer sharing, IPv4, so on and so forth. All those options that you were reading about in your lesson. If I click that configure button that we just talked about, you can see here are those adapter properties. These are the driver properties. If I click that advanced tab, there's all those different options of how you can configure this. Now let's compare that to a physical adapter. Let's see if it's any different. In fact, what I'm going to do is I'm going to minimize this. Oh, I can't minimize that. Let's go to configure. I can't do it. That's because this is being NIC teamed. Okay, so here is our live system. So understand that this system has four physical network adapters: Ethernet, Ethernet 2, Ethernet 3, and Ethernet 4. I've combined those into two NIC teams of 2 adapters each. If I want to manage the adapter settings, I can no longer manage the physical adapter settings because they're being managed in the NIC team. I have to do it through the NIC team properties. If I want to manage these individually, I would have to destroy the NIC team first. The NIC team gets configured with its own unique settings. So if we look here, let's take a look at the properties. Let's see if we can view the properties for this. Here we can see our properties. Then this is the same thing that you'll see when you set it up. You'll give it a name, you'll select the network adapters that are going to be part of the team, and you'll select the way that the team is being created. So here you can see that there's 2 network adapters selected. The teaming mode switch independent, the load balancing mode is dynamic, and there's no standby adapter. So what's a standby adapter? If I had other adapters, I could take those and put those as a standby adapter. I could select one of these to be a standby adapter. That would say Okay, let's say I had 4 network adapters in here, and 2 are connected to one switch and 2 are connected to another switch. I could put one of those to be a standby adapter. So if one of these fails, it would bring this online and allow it to operate. These are your NIC options. What about SET, switch embedded? Let's get out of here, and remember, switch embedded teaming is done by configuring on PowerShell. So back in your lesson, here is that remote direct memory access with SET, switch embedded teaming. Remember, switch embedded teaming creates a virtual switch in Hyper-V and directly combines your physical adapters that you specify. You're not creating a NIC team and then creating a network switch. You're creating a network switch, a virtual network adapter that directly accesses those Ethernet adapters. To create a set team, you have to do it through PowerShell. And you use the new VM switch command. You include the enable embedding teaming parameter in your syntax. So for example, to create a new virtual switch called Team2 switch, and you want it to include NIC number 1 and NIC number 2 on your physical system, here is your PowerShell command. So you're saying, I want to create a new virtual switch. The name in Hyper-V Manager will be Team2 switch. The network adapters that will be combined in that switch will be NIC 1 and NIC 2, and you are going to enable embedded teaming, and you say that's true. That's how you go about doing that. So lots of different options for using SET and RDMA. So I hope that gives you a little bit better insight into your lesson. Please be sure to read it through it thoroughly and understand all the concepts. There's a lot of different concepts in this section of high performance network solutions. Thank you.